In this session, I will show you what is the ASCII T-Search and its main functionalities and how to use it. T-Search is a search tool designed to aid the error analysis and output and detect the errors in the output of the automatic translations. Because the task of manually inspecting a real test bed of 3,000 sentences is practically unfeasible. So T-Search makes focused exploration on search in these medium to large size datasets and helps reducing the human effort and time and thereby cost in MT development. The search can be used through the command line along with the ASCII toolkit, but its main contribution is a graphical web application that allows an interactive usage of T-Search in combination with the ASCII Online interface. The main functionalities of T-Search are to find concrete translation examples within the translation testbed that have specific characteristics, including some linguistic features. And the second functionality is to clearly spot the divergences among several candidates and references, translations that make them good or bad according to some user criteria. I will show you here a general example. Consider an evaluation setting where we have two hypothetical empty systems, S1 and S2. Consider also that we have two evaluation metrics, M1 and M2. And we observe that M1 scores S1 to be better than S2 in the dataset, while M2 predicts just the contrary. So in order to analyze this contradictory evaluation, one might be interested in inspecting which are the particular translation examples in the dataset that contributes to these results. In other words, one needs to find the sentences for which the translations produced by S1 are scored by M1 higher than the translations produced by S2, and just the opposite with metric M2. The T-Search allows to efficiently retrieve and visualize and export these sentences running a query example. For instance, in this example, we had a query where we want to all the segments from S1 scored by M1 higher than 0.7, and also all the segments from S2 that M1, the metric M1 scored below 0.3. And the same conditions by changing the order of M1 by M2 here and here, and where M2 is scoring system 1 below 0.3, and M2 is scoring S2 above 0.7. So the T-Search architecture consists of three documents. On the one side, there is the query parser and search engine, which solve the user query and retrieve combined information from the database. How is this database load? The database is the place where we save the scoring on all the linguistic information that ASCII toolkit has calculated before. This information is loaded into the database through the T-Search API and data loader. Then the T-Search interface assists the user to write the queries and display the search results, and allows to export also the results in XML format. Let's see as well a demo of how T-Search works. Hello. In this demo session, I will show you how to use the T-Search tool. Its main objective is to facilitate the qualitative analysis of the quality of your automatic translations. The T-Search tool allows you to find those sentences that match some criteria that match some specific criteria related to the linguistic elements or the scores. So in this button, we access to the interface. You see, it's very simple. Here, you have a toolbar where you will find all the measures that we have calculated. You can find here all the systems that belong to our dataset, and the documents in case they are here. Then here we can create, for instance, a group of measures that we want to operate with. Let's select BLEU and the STPs, for instance. and create the group 1. Then here we can also create a group of systems. For instance, we will select these 3 to operate with. Here you will find also all the statistical variables that you can use for your queries. And let's write one of our queries. Now we will obtain all the sentences that belong to the group system S1 that have the scores for the measures group 1 above the average. In this box here, you can find the information about your query you just have performed. Here is the group of systems, the group of measures, and the average for the 2 measures that we have selected. This is the average for the Blair score, and this is the average for the constituency parser measure. As a result, the search is showing you 3 different views. In this first one, you will find all the sentences that match your query and the scores obtained for each of them. In this other view, you will see all the sentences organized in a system basis. Here you have all the sentences that belong to the Apertium system, and here the ones that belong to the Babelfish system. In the last of the views, you can see the segments organized by segment. This is a very interesting feature where you can, because it allows you to compare easily all the sentences, the differences between the sentences of translation of the same segment. Also, when you move your mouse over the sentences, you will see additional information about which is the segment which is the segment number that the sentence belongs to, which is the document, and which are the systems and the reference used to obtain the scores. You can also export these results in XML file as an XML file. So you can later process them out as you wish. The search allows you to obtain also linguistic elements-based queries. For instance, let's find for those sentences that have some nouns, and let's find also the sentences that have had and dependents related with a dependency relation of type subject. In case you do some errors writing your queries, the system will tell you what are the some hints to solve the problems. As a result, this search is showing you all the sentences that match your query, and you can also see the annotation over the sentences. Here you see that there are some sentences having nouns and noun phrases as a head of your dependency relation. And some verbs and nouns as dependents. Finally, if you need some help writing your queries, you can tap here and you will see some examples about how to write complex queries based on linguistic elements, semantic roles, dependency parsing, or constituency parsing, and how to create different types of groups, and how to combine all kinds of queries, both linguistic elements based and metrics scores based. That's all. Thanks for your attention.